All right, let's talk about something that's easy to forget about until it's gone. I'm talking about your power, especially when it's freezing outside. A few years back, a polar vortex brought a huge part of our grid to its knees. So today, we're going to dig into the brand new rulebook that's been put in place to make sure that never happens again. You probably remember it, right? February 2021. It wasn't that long ago. A massive cold snap just rolled across the middle of the country, and right when people needed heat the most, the lights went out for millions. It was a huge wake-up call. I mean, it showed us all just how fragile our energy system really was.
So that leads to two really big questions. First, how on earth did our power system fail so badly? And second, maybe the most important question of all, what are we actually doing to keep it from happening again? Well, that's exactly what we're going to unpack.
Okay, so first things first, let's rewind the clock a bit and look at what actually happened during that freeze, because you really can't understand the solution until you get a good handle on the problem. And to really get a sense of just how massive this was, think about this. When you look at the sheer amount of power that grid operators had to deliberately cut off just to stop a total collapse, this was the third largest blackout in the history of the United States. Only two other events, way back in 2003 and 1996, were bigger. That's huge. Now check out the exact wording from the official report. It says this was the largest controlled load shed event. And that word controlled is key. It means this wasn't an accident. Grid operators were making the gut-wrenching decision to cut power to millions of us on purpose, because the alternative was an even bigger, totally uncontrolled collapse of the entire system. It was the absolute last resort. So, as you can see, the response wasn't some quick knee-jerk reaction. After the crisis, regulators went deep. They launched a massive investigation to figure out exactly what went wrong. And that investigation led to a whole set of recommendations, which, after a few years of work, became a brand new, much tougher standard that was finally approved in mid-2024. And that's the rulebook we're digging into today. Okay, so if you're going to write a new rulebook, where do you even start? Well, you start with definitions. You can't force a power plant to prepare for extreme cold if you can't even agree on what extreme cold actually is. Just telling them to get ready for winter, that obviously wasn't working. And this is where it gets really smart. They came up with something called the Extreme Cold Weather Temperature, or ECWT for short. Think of it like a final exam for every single power plant. It's not just some random number. It's a very specific, localized temperature. And it's not simply the coldest day on record. It's a data-driven benchmark that each plant has to prove it can survive. So how do they figure this out? Well, they take all the hourly temperature data for that specific location every winter, going all the way back to the year 2000. And here's the brilliant part. Instead of just picking the single lowest temperature ever, they find the 0.2 percentile. What that does is it filters out those bizarre 1 in a million fluke days. It gives you a number that is a true, statistically sound worst-case scenario. That number becomes the plant's official target. Okay, but you can't just wrap an entire power plant in a giant winter coat, right? It's not practical. So the rules get really specific. They focus on what they call generator cold weather critical components. The easiest way to think about these are the plant's exposed vital organs. We're talking about things like sensing lines, fuel pipes, the small, vulnerable parts that if they freeze, the whole power plant goes down. All right, so now we've got a target temperature, and we've got a list of the critical parts to protect. So let's look at how the new rulebook actually puts those two things together to make our grid stronger. So the new rules basically create two different standards. For all the power plants that already exist, the mission is pretty clear. You have to upgrade your gear so you can run at your specific ECWT. Simple enough. But for any new plants, well, the bar gets raised way higher. Starting in late 2027, they have to be designed from scratch to not only handle their ECWT, but to do it while getting hit with a steady 20-mile-per-hour wind for 12 straight hours. That's a whole other level. And to make sure all this actually happens, every single generator owner now has to create and maintain a cold weather preparedness plan. And believe me, this is not just some piece of paper you file away and forget. It's a living document, it's auditable, it forces them to prove every single year that they've done their inspections and their protections are ready to go. The whole point is to shift the industry from just reacting to disasters to actively preventing them. So the plans are there, the preparations are made, but what if a generator fails anyway? What happens then? Well, this is where the new rules really get serious.
The rules create a clear red line, what they call a generator cold weather reliability event. Basically, if a plant has a failure because something froze, and this is the important part, it happens when the temperature is warmer than its official target temperature, then a mandatory process kicks in. You can't just say, oh, it was too cold, if you fail the very test you were supposed to be prepared for. No more excuses. The second that red line is crossed, a clock starts ticking. The plant owner has to launch a corrective action plan, or a CAP. They have to figure out exactly what broke, write a plan to fix it, and here's the kicker, they have to get that fix completely finished before December 1st of that same year. The whole idea is to make sure the same problem doesn't bite them again just a few months later. And this is maybe one of the biggest changes. The accountability doesn't just stop with the one plant that failed. No way. A failure at one single unit, that triggers a mandatory review across the company's entire fleet. They have 12 months to check all their other similar plants for that exact same vulnerability. It's about finding the systemic problem, killing the weed at the root, instead of just fixing the one symptom.
So you might be wondering, are there any exceptions, any get-out-of-jail-free cards? The answer is yes, but they are incredibly rare and very, very strict. It's called a generator cold weather constraint, but it's not a loophole. Think of it like getting a doctor's note. You have to formally prove to regulators that a fix is truly impossible for some real engineering or structural reason. And even then, that note gets reviewed every 3 years just in case new technology comes along that makes a fix possible. Okay, so we've gone from a catastrophic failure to a totally new system built on data, plans, and some serious accountability. Which brings us to the big one, the question that really matters. So at the end of the day, after all of this, will it actually work? Will the lights stay on next time a polar vortex comes knocking? Here's what it all boils down to. This new standard really does change the game. We're moving away from vague ideas and into a world of hard data with a specific temperature target for every plant. We've got real accountability, where a failure kicks off a mandatory fix with a tight deadline. A problem at one plant now has to be checked everywhere, and the loopholes are being sealed shut. Now look, nothing is ever 100% foolproof, but this new system makes another 2021-style disaster way, way less likely. But that leaves us with one final, pretty big question to think about. We've built a really solid rulebook to fix the exact problems that caused the last crisis, but as our weather gets more and more extreme, is just hardening our power plants against the cold actually enough? Or are there other weak spots, other vulnerabilities hiding in our massive energy grid, just waiting for the next new challenge that we haven't even thought of yet?